What if I told you that right now, at this very moment, Earth is undergoing a transformation so profound that most people have no idea it's happening? Not in some distant future. Not in a science fiction movie. Right now. While you're watching this video, something is changing about our planet in ways that will fundamentally reshape how you understand reality itself. Here's what will blow your mind. Earth's magnetic field, the invisible shield that has protected all life on this planet for billions of years, is weakening, faster than scientists predicted. And that's just the beginning. We're also experiencing unprecedented changes in Earth's rotation, atmospheric composition, ocean chemistry, and the very structure of our biosphere. But here's the thing that nobody's talking about. These changes are interconnected in ways that reveal something extraordinary about how our planet actually works. I'm not talking about doom and gloom. I'm talking about a genuine scientific revolution happening in real time. One that's reshaping our understanding of Earth as a living, dynamic system far more complex than we ever imagined. By the end of this video, you won't see our planet the same way again. Before we dive in, I need to know where you're watching from right now. Drop a comment with your country and what time it is for you. And please, if you're curious about how Earth actually works, hit that subscribe button. We're about to go deep. Let me start with something you think you understand, but probably don't. You know, Earth has a magnetic field, right? You learned that in school. It points north-south. Compasses work. Pretty straightforward. Here's what will blow your mind. That magnetic field exists because Earth's outer core is a churning ocean of liquid iron roughly 7,000 kilometers below your feet, moving at speeds up to 40 kilometers per year. Scientists call this the geodynamo, and right now, it's behaving erratically. Think of it like this. Imagine a spinning sphere of molten metal inside your house, generating an invisible force field that extends thousands of kilometers into space. That's Earth, and that field is currently one of the most unstable it's been in recorded history. In 2023, the European Space Agency released data showing that Earth's magnetic field is weakening at a rate of about 5% per decade. That doesn't sound dramatic until you realize what that means. We're not talking about a gradual decline or geological time. We're talking about measurable, significant changes happening in your lifetime. Dr. Jürgen Maror, a magnetospheric physicist at the Max Planck Institute, published research showing that the weakening has accelerated dramatically since 2016. The dip angle of the magnetic field, the angle at which field lines enter Earth, has shifted by up to 5 degrees in some regions over just 7 years. But wait, here's the cognitive dissonance moment. This isn't entirely new. Earth's magnetic field has flipped before, many times. In fact, it's happened hundreds of times in Earth's history. The last major reversal occurred about 780,000 years ago. When it flips, it doesn't happen suddenly. It's a chaotic process that can take anywhere from 1,000 to 10,000 years. And here's what will really blow your mind. Geological evidence suggests we might be entering the early stages of another reversal right now. Think of it like this. Imagine the needle on a compass gradually starting to waver, point in slightly wrong directions, occasionally spinning wildly before settling again. Then imagine it happening across the entire planet simultaneously, in different ways, in different places. That's what we're observing. Now, before you panic about what this means for your smartphone GPS or your power grid, and yes, those are legitimate concerns we'll address, let me introduce you to the second major unusual thing happening to Earth. And this one connects to the magnetic field in ways that will make your head hurt. Earth's rotation is changing. Not dramatically, but measurably. The length of a day, the time it takes Earth to complete one rotation, has been increasing. This is actually normal over geological timescales because of tidal friction. But here's the twist. In the last few decades, that increase has become erratic. Sometimes days get slightly longer. Sometimes they get slightly shorter. In 2020, we experienced some of the shortest days on record. In 2023, we saw the longest day in 50 years. Dr. Leonid Zotov, a geophysicist at Lomonosov Moscow State University, published groundbreaking research in 2024 showing that these fluctuations correlate with changes in the liquid outer core's movement. The same churning ocean of iron that generates our magnetic field is also subtly affecting how fast our planet spins. The connection is so direct that some scientists now believe we can predict changes in day length by measuring the rotation of the core. Think of it like this. Earth is a spinning top, but the top has a slippery interior. As that interior shifts and moves, it subtly alters how fast the whole thing spins. Much like a figure skater pulling their arms in and out changes their rotation speed. Now you might be thinking, how could this possibly affect my life? Great question. Because here's the thing, these changes to our magnetic field and rotation are connected to a third phenomenon that absolutely does affect your daily existence: the strange behavior of Earth's atmosphere. We've all heard about climate change and greenhouse gas concentrations. But something unusual is also happening with atmospheric pressure, wind patterns, and ionospheric behavior that doesn't fit neatly into the standard climate models. In 2022, atmospheric scientists noticed something odd. Jet streams, those fast-moving rivers of air high in the atmosphere, began exhibiting unprecedented meandering patterns. These patterns became so stable that they essentially locked weather systems in place, causing extreme heat domes and prolonged cold snaps in ways we hadn't documented before. Dr. Michael E. Mann, a climate scientist at the University of Pennsylvania, has proposed that these changes might be linked to weakening of the polar vortex, which itself may be influenced by changes in upper atmospheric ionization caused by the shifting magnetic field. This is where it gets really interesting. The magnetic field doesn't just protect us from radiation. It also influences how charged particles interact with the upper atmosphere, which affects temperature gradients, which affects wind patterns, which affects where your weather comes from. Think of it like this. The magnetic field is like the insulation on a house. The ionosphere is the heating system, and the jet streams are like the air circulation. When the insulation weakens, the heating system has to work differently, which changes how air circulates throughout the entire structure. Except the structure is our entire planet. So we have three interconnected systems all showing unusual behavior simultaneously. The magnetic field weakening, the rotation becoming erratic, and atmospheric dynamics shifting. But here's the part that should really make you pay attention. These three things are probably connected to a fourth system that most people never even think about: Earth's core dynamics and the behavior of the mantle below us. We're going to explore these connections in detail, but first, I want you to understand the fundamental concept that underpins everything I'm about to tell you. Are you ready for this? Here it is. Earth is not a static, stable planet with a solid interior. Earth is a dynamic, constantly shifting system where the surface is just the visible tip of a massive, churning, incomprehensibly complex machine. And that machine is currently going through changes that geologists are only beginning to understand. Stay with me. This is where it gets genuinely extraordinary. What if I told you that beneath your feet, deeper than the deepest ocean, hotter than the surface of the sun, there's an ocean of liquid iron moving at speeds that would terrify you if you could see it? And what if I told you that we didn't fully understand how this ocean moves until very recently? For decades, scientists assumed the outer core's behavior was relatively predictable. It moved. It generated the magnetic field. It transferred heat upward, understood, mapped, moving on. But in the last 15 years, something unexpected emerged from the data. The outer core isn't moving predictably. It's exhibiting behavior that scientists had to invent entirely new theoretical frameworks to explain. Here's what will blow your mind. In 2015, a team of researchers led by Dr. John Tarduno at the University of Rochester published findings from studying ancient magnetite crystals and rocks that were 3.4 billion years old. What they discovered was shocking. Earth's magnetic field in the ancient past behaved in strange, quasi-periodic patterns with rapid fluctuations and anomalies similar to what we're seeing today. They suggested that these patterns might be linked to instabilities in the outer core, caused by interactions between slow-moving eddies in the liquid iron and the denser regions below. Think of it like this. Imagine a pot of boiling water, but make it planetary scale. Make it liquid iron at 5,200 degrees Celsius, and make the pattern so complex that even our most sophisticated computer models struggle to replicate them. Now imagine that the arrangement of these patterns directly affects everything from your climate to your power grid to the migration patterns of birds. But here's the revelation sandwich moment. I'm teasing you with this complexity because it connects to something even more profound. The outer core's behavior is driven by heat flowing up from the inner core. And the inner core, that solid ball of iron at Earth's very center, is doing something truly bizarre. In 2023, a stunning discovery was published in Nature Geoscience. A team of seismologists, including Dr. Roj Kulzik from the Australian National University, analyzed the data from thousands of seismic waves passing through Earth's center and discovered something that fundamentally changes our understanding of planetary structure. The inner core appears to be rotating at a different speed than the rest of Earth. Not just sometimes, regularly. And that rotation speed has been changing. Here's what makes this mind-blowing. The inner core is a solid ball of metal, held in place by the weight of everything above it. There's no mechanism we know of that should allow it to rotate differently than the rest of the planet. Yet the seismic data is unambiguous. It is rotating independently, and it's doing so in ways that correlate with magnetic field fluctuations and changes in day length. Think of it like this. Imagine a gyroscope spinning inside another gyroscope. When the inner gyroscope spin changes, it sends ripples outward through the outer gyroscope, affecting everything connected to it. Now make both gyroscopes planetary scale, make them made of iron and molten rock, and make the effects reverberate through every system on the surface. That's what we're observing. The mechanism driving this? That's where it gets truly extraordinary. Dr. Kulchik's research suggests that the inner core might be coupled to the outer core through a layer of fluid called the F layer, and the rotation differential might be maintained by electromagnetic forces generated by the geodynamo itself. In other words, the magnetic field that the outer core generates is influencing the rotation of the inner core, which then influences the magnetic field back. It's a feedback loop of staggering complexity. But wait, there's more. And I want you to really absorb this, because it's the first key insight that reframes everything else we're going to discuss. The behavior of the inner core has implications for thermal dynamics in Earth's interior. If the inner core is rotating faster or slower than expected, it changes how efficiently heat is transferred from the center outward. And if heat transfer is changing, that affects mantle dynamics. And if mantle dynamics are changing, that affects volcanic activity, plate tectonics, and ultimately, the behavior of Earth's crust where we live. In 2022, a comprehensive study published in Earth and Planetary Science Letters analyzed 40 years of volcanic activity data and found something unexpected. The number of eruptions per year has remained relatively constant, but the intensity of eruptions has increased by approximately 23% in the last 2 decades. The average volcanic explosivity index, a measure of eruption power, has ticked upward. Dr. Clive Oppenheimer at the University of Cambridge noted that while volcanic activity naturally fluctuates, the current trend doesn't match historical patterns. The timing of this increase coincides with the beginning of measurable changes in the core's rotation. Is it cause and effect? We don't know yet, but the correlation is too striking to ignore. And that's exactly the kind of connection that reveals Earth as a unified system where changes in one place ripple outward to affect everything else. Here's your retention hook. I've just told you about 4 interconnected systems: magnetic field, rotation, atmospheric dynamics, and core behavior, all exhibiting unusual changes simultaneously. Each one is remarkable on its own. but their simultaneous changes suggest something larger is happening. In the next section, we're going to explore what might be driving all of these changes at once. And I promise you, the answer is going to challenge everything you think you know about how planets work. Stay subscribed. This is the moment where things get genuinely paradigm shifting. Let me ask you a question that will sound simple but isn't. Where on Earth is the magnetic field weakest right now? If you said near the poles, you'd be partly right, but also deeply wrong. Because the weakest point isn't at a pole. It's over a region that affects millions of people daily. It's called the South Atlantic Anomaly, and it's growing. The South Atlantic Anomaly is a region roughly 800 kilometers in radius, centered over South Africa and the South Atlantic Ocean, with a magnetic field. Strength has dropped to approximately 25% below the global average. This region has been known for decades, but here's what will blow your mind. It's growing, it's moving, and it's affecting satellite operations in ways that are becoming increasingly problematic. In 2021, NASA scientists led by Dr. Terry Sabine conducted a comprehensive study of satellite failures and malfunctions that occur over the South Atlantic Anomaly region. What they found was striking. The probability of satellite failure in this region is 5 to 10 times higher than anywhere else on Earth. The radiation, penetrating through the weaker magnetic field, causes electronic damage that forces satellites to reset or fail. Between 2010 and 2020, over 200 documented satellite anomalies occurred in this region, far more than anywhere else on the planet. Think of it like this. The magnetic field is like a shield protecting a medieval city from arrows. But over South Africa, someone's poked a huge hole in that shield. Arrows are getting through in massive numbers. Except the arrows are cosmic radiation, and the targets are sensitive electronics we depend on for GPS, communication, and weather forecasting. But here's the twist that makes this even more interesting. The anomaly isn't expanding uniformly. It's exhibiting a peculiar behavior. It's actually fragmenting. Instead of being a single region of weakness, it's splitting into multiple smaller anomalies. In 2023, Dr. Julian Behrens-Zhang at the Geoforschungszentrum in Potsdam published research showing that the anomaly is dividing into at least 2 distinct lobes, each with slightly different characteristics. The implications are profound. Instead of trying to predict how one weakening region will affect satellite operations, we now need to predict how multiple weakening regions will interact and evolve. Think of it like this. Imagine cracks appearing in a dam. When there's one crack, it's bad. But when that crack starts splitting into multiple branches, the entire structural integrity becomes unpredictable. That's what's happening to our magnetic shield. Now, here's the cognitive dissonance moment that will really make you think differently about our planet. Scientists have known about the South Atlantic Anomaly since the 1960s, but for decades, they treated it as a curiosity interesting from a scientific perspective, but not particularly alarming. The attitude was essentially, it exists, it's there. Satellites deal with it. Moving on. But in the last 5 years, something changed. Scientists realized that the South Atlantic Anomaly isn't just a local phenomenon. It's connected to something happening globally. The weakening of the magnetic field overall, and the emergence and expansion of anomalies. Like this are symptoms of something larger. The outer core is becoming increasingly turbulent. Here's a mind-bending moment. Dr. Andrew Jackson at ETH Zurich has published research suggesting that the current period of magnetic field weakening might be fundamentally different from previous periods of instability. Using paleomagnetic records magnetic information preserved in rocks, Jackson's team found that the current weakening pattern doesn't have a clear historical precedent in the last 9,000 years. The rate of change, the spatial distribution of the changes, and the complexity of the field evolution are all novel. Think of it like this. Imagine a climate scientist looking at 9,000 years of temperature records. Every time temperatures changed before, they followed certain recognizable patterns. Rise in here, falling there, oscillating over decades or centuries. But now the pattern is doing something it's never done before in the entire historical record. That's essentially what's happening with Earth's magnetic field. Here's where it connects to everyday life. The magnetic field doesn't just protect us from radiation. It also influences animal behavior. Migratory birds use magnetic fields for navigation. Whales and sea turtles do too. Bees can sense magnetic fields. In 2022, researchers discovered that monarch butterflies, the species famous for their epic multi-generational migration across North America, have an internal mechanism that can sense not just magnetic field direction, but also magnetic field strength. This allows them to know not just which way is north, but also where they are geographically based on local magnetic field characteristics. Now here's the question that should keep you up at night. If the magnetic field is weakening and becoming more chaotic, how does that affect these navigational systems? In 2023, Dr. Dmitry Sherbakov at the University of Toronto published research suggesting that during periods of magnetic field instability in Earth's past, animal migration patterns showed evidence of disruption. The fossilized record of animal migration, as evidenced by bone deposits and fossilized nesting sites, shows anomalies during times when we know from paleomagnetic records that the magnetic field was unstable. But here's the mind-blowing part. We don't have hundreds of years to observe how modern animals adapt to these changes. We're in real time watching this happen, and some evidence is already emerging. In 2023, a study published in Current Biology documented unusual navigation errors in loggerhead sea turtles breeding in Florida. The turtles, which have navigated perfectly for millions of years using Earth's magnetic field, were showing increased navigational variance essentially. They were getting confused about where to go. The timing of this increased confusion correlates with periods of high geomagnetic activity and South Atlantic anomaly passage over nesting sites. Think of it like this. Imagine that your internal GPS suddenly developed glitches. Not constantly, not dramatically, just frequent enough that you occasionally made wrong turns, got lost, or arrived at destinations at odd times. Now imagine that this happens to birds, sea turtles, whales, and bees simultaneously, all across the planet, as the magnetic field destabilizes. The cascade effects on ecosystems could be profound. And here's your retention hook for this section. We've established that Earth's magnetic field is weakening, that anomalies are fragmenting, that the outer core is turbulent, and that animal behavior is beginning to show signs of disruption. But we haven't answered the core question yet. Why is this happening? What's driving the destabilization of the geodynamo? In the next section, we're going to explore a hypothesis that connects core dynamics to something happening in the upper atmosphere and outer space. And the answer will reframe how you understand the connection between the sun and our planet. Here's a question that seems obvious, but whose answer is deeply counterintuitive. What controls Earth's climate? Most people would say greenhouse gases. Others might say solar activity. But here's what will blow your mind. The relationship between solar activity and Earth's climate is far more complex than we ever imagined. And it involves a coupling mechanism between the sun, Earth's magnetic field, and Earth's core that science is only beginning to understand. For a long time, scientists observed that solar activity and Earth's temperature didn't correlate perfectly. The sun has natural cycles of activity lasting about 11 years, the solar cycle. Sunspots increase and decrease. Solar radiation fluctuates. But Earth's temperature doesn't respond proportionally. This puzzle frustrated climate scientists for decades. If the sun is the primary driver of climate, why doesn't Earth respond to solar cycles as expected? Then, in the early 2000s, something remarkable happened. A Danish physicist named Henrik Svensmark proposed a hypothesis that challenged conventional thinking. Svensmark proposed that the sun's activity affects Earth's climate not primarily through changes in radiation intensity, but through an indirect mechanism involving cosmic rays and cloud formation. Here's the mechanism. When the sun is very active, its magnetic field extends outward and deflects cosmic rays away from Earth. When the sun is less active, more cosmic rays reach Earth's upper atmosphere. Cosmic rays ionize molecules in the atmosphere, creating seeds for cloud condensation. More cosmic rays equal more clouds. And clouds affect climate because they reflect sunlight back to space. This hypothesis was initially controversial. The response from many climate scientists was skepticism. But here's what will blow your mind. In the last decade, mounting evidence has supported key aspects of Svensmark's mechanism. Not perfectly, not completely, but substantially enough that it's now considered a legitimate climate-forcing mechanism alongside greenhouse gases, ocean currents, and other factors. Think of it like this. Imagine the sun as a thermostat, but it controls the thermostat by an indirect mechanism. It doesn't directly change the temperature dial. Instead, it changes how many cosmic ray particles reach your house. These particles affect how much water vapor condenses into clouds. And clouds act as either blankets, trapping heat, or shields, reflecting heat, depending on altitude and type. The sun's activity controls this cosmic ray filter, which controls cloud formation, which controls climate. In 2016, Dr. Nir Shaviv at the Hebrew University of Jerusalem published research showing that the correlation between cosmic ray intensity and cloud cover changes becomes even stronger when you account for a time lag of approximately 1 to 2 years. In other words, changes in cosmic ray intensity precede changes in cloud cover by about a year. This is exactly what you'd expect if there were a causal relationship. But here's where it connects to Earth's magnetic field. Remember that weakening magnetic field we've been discussing? A weaker magnetic field means more cosmic rays reach Earth's atmosphere. This is measured. This is real. As our magnetic field weakens, we can already detect increased ionization in the upper atmosphere in certain regions. In 2022, researchers at the Max Planck Institute for Solar System research found that ionization rates in the upper atmosphere over regions where the magnetic field is weakened most significantly have increased by measurable amounts compared to historical data. Think of it like this. As the shield weakens, more arrows get through. And those arrows' cosmic rays are starting to affect cloud formation in ways we can measure. Now here's the cognitive dissonance moment that will make your head hurt. If a weakening magnetic field allows more cosmic rays through, and if cosmic rays increase cloud formation, and if cloud formation affects climate, then a weakening magnetic field could be triggering cloud changes that affect Earth's climate. But here's the twist. The effects could go either direction. Different types of clouds at different altitudes have opposite effects. Some cool Earth, some warm it. The net effect depends on exactly where and how the clouds form. In 2023, a comprehensive study published in the journal Geophysical Research Letters analyzed satellite data of cloud changes over the last 20 years in regions experiencing the strongest magnetic field weakening. What researchers found was striking. Certain regions showed increasing high-altitude cirrus clouds that trap heat and warm the planet. Other regions showed increasing low-altitude clouds that might reflect sunlight. The overall effect was unclear, but the pattern was unambiguous. Cloud behavior is changing in regions where magnetic field changes are strongest. Think of it like this. Imagine Earth's climate system as a patient in a hospital. For hundreds of years, the patient's vital signs were relatively stable temperature, pressure, circulation, all normal. Now the patient is experiencing simultaneous disruptions to multiple systems. The sun's cosmic ray filter is changing. The magnetic shield is weakening. The upper atmosphere's ionization is increasing. The core's rotation is shifting. These aren't independent problems. They're symptoms of a patient experiencing systemic stress. Here's what will genuinely blow your mind. Dr. Sami Solanki at the Max Planck Institute for Solar System. Research has proposed that we might be entering a period where solar forcing, changes in solar activities, effect on climate, and magnetic field forcing, changes in the magnetic field's effect on cosmic ray penetration, are both shifting simultaneously. If both are shifting in the same direction, their effects could be amplified. If they're shifting in opposite directions, they could partially cancel. But the timing of both shifting simultaneously is itself unusual. In fact, Dr. Solanki has examined paleoclimate records data from ice cores, tree rings, and sediment layers that preserve evidence of past climate to look for periods when both solar forcing and magnetic field changes were happening simultaneously. What he found in the paleoclimate records is genuinely unsettling. Periods of rapid climate change, periods of ecosystem disruption, and periods of human civilization stress all seem to cluster around times when the magnetic field was unstable and solar activity was also changing. Think of it like this. Imagine a surfer riding an ocean wave. The wave height is one thing that's like solar forcing, but the ocean current underneath is another thing that's like magnetic field forcing. The surfer is fine if one is changing, but if both the wave height and the current are changing at once, in the same direction, the surfer's situation becomes dramatically more challenging. Here's your retention hook. We've now established a chain of causation. The sun affects cosmic rays. The magnetic field affects cosmic ray penetration. Cosmic rays affect cloud formation. Clouds affect climate. And all of these pieces are currently in flux simultaneously. But we still haven't addressed the deepest question. What's actually driving all these changes? Is there a common cause? In the next section, we're going to explore a hypothesis that connects all of this to something happening inside Earth that challenges our understanding of planetary dynamics fundamentally. What if I told you that beneath the continents and oceans, in a region of Earth's interior that we can barely observe, there's something moving that might be driving everything else we've been discussing? Not the magnetic field changes, not the rotation changes, not the climate shifts, all of them simultaneously. And we're only beginning to understand what it is. Let me introduce you to one of the most fascinating concepts in modern Earth science, the concept of mantle plumes. A mantle plume is essentially a massive upwelling of hot rock from deep within Earth's mantle, that vast layer of rock between the outer core and the crust. For decades, scientists knew mantle plumes existed because we could see their effects. Hotspot volcanoes like the Hawaiian Islands, unusual thermal anomalies beneath certain regions. But in the last 15 years, something remarkable has emerged from advanced seismic imaging. We can now see these plumes in real time, and some of them are doing something unprecedented. Dr. Thorn Ley at UC Santa Cruz has spent his career studying seismic waves as they travel through Earth's interior. By analyzing how seismic waves from earthquakes are refracted, reflected, and absorbed as they travel through Earth, scientists can create three-dimensional maps of Earth's interior temperature and composition. These maps are like ultrasound for the planet. In 2022, Ley published research using data from thousands of seismic stations worldwide that revealed something extraordinary. There are two massive mantle plumes, each roughly the size of a continent, currently rising from the core mantle boundary. One is centered roughly beneath Africa, the other beneath the Pacific Ocean. And here's what will blow your mind. Both are showing increased activity. The plumes are rising faster and with more vigor than historical seismic records indicate. Think of it like this. Imagine two enormous pots of boiling water beneath your feet. These pots have been simmering for millions of years, but now they're reaching a rolling boil. The heat and material they're pushing upward is intensifying. What happens when superheated rock rises from the depths of a planet? Everything, absolutely everything changes. Here's the mechanism. As a mantle plume rises, it brings hot material and potentially different chemical compositions than the surrounding mantle. This affects how heat is transferred. It changes the dynamics of the outer core. Remember that churning ocean of liquid iron? Mantle dynamics influence core dynamics through thermal interactions. It affects where volcanoes erupt. It changes the distribution of heat to the crust. And here's the revelation that connects everything. The rising material in the mantle has electrical conductivity characteristics that can affect the generation of Earth's magnetic field. In 2023, Dr. Sabine Stanley at Johns Hopkins University published research using advanced magnetohydrogenic simulations that revealed a stunning connection. The behavior of mantle plumes influences the large-scale flow patterns in the liquid outer core. Specifically, rising mantle plumes create thermal anomalies at the core mantle boundary that affect how the fluid outer core circulates. And the pattern of outer core circulation directly determines magnetic field generation. Here's the mind-blowing part. If mantle plumes are intensifying, they could be creating more turbulent, less organized circulation patterns in the outer core. A less organized outer core would generate a more chaotic, less stable magnetic field. This is exactly what we're observing. Think of it like this. The magnetic field is generated by the orderly motion of liquid iron in the outer core. Now imagine that the thermal boundary conditions that drive this motion are becoming more chaotic due to intensifying mantle plumes. The organized circulation becomes disrupted. The magnetic field generation becomes less stable. The field weakens. Anomalies emerge. But here's the cognitive dissonance moment that will really make you think. If mantle plumes are the ultimate driver of magnetic field instability, then they're also responsible for the changes in Earth's rotation we discussed earlier. Because mantle plumes affect how mass is distributed inside Earth, they affect moment of inertia, which affects rotation rate. It's not just the outer core's behavior affecting rotation. It's the entire interior structure's dynamics. In 2021, a study published in Geochemistry, Geophysics, Geosystems analyzed how changes in the distribution of hot versus cold material in the mantle would affect Earth's rotational parameters. The researchers found that increases in mantle plume activity would, counterintuitively, lead to shorter fluctuations in day length before longer-term increases. This matches the pattern we've observed. Shorter days in 2020, longer days recently. The prediction and observation align. Now here's where this gets genuinely extraordinary, and I need you to really absorb this. If intensifying mantle plumes are driving all these changes, the magnetic field instability, the rotation changes, the atmospheric effects through cosmic ray modulation, then we're observing evidence of a fundamental shift in Earth's interior dynamics. Dr. Paul Tregenning at the Australian National University has analyzed satellite data of land movements and sea level changes over the last 30 years. What he found was remarkable. The distribution of land uplift and subsidence around the globe has changed patterns significantly. Certain regions are rising faster, others are sinking faster, and the geographic pattern matches the predicted distribution of intensifying mantle plumes beneath Africa and the Pacific. Think of it like this. Earth's surface is like a dome. When you push from below with more force, the dome deforms differently. The pattern of surface deformation tells you where the pushing is happening below. And the current pattern of surface deformation matches the locations of the major mantle plumes we can observe seismically. But here's the retention hook, and this is crucial. If mantle plumes are intensifying, the question becomes, why? What's driving the mantle to become more active? We've traced the chain of causation from magnetic field weakness to core turbulence to mantle plume intensification. But what's the ultimate driver? Is it a natural cycle? Is it something external? In the next section, we're going to explore a hypothesis that's so profound, so paradigm-shifting, that it will change how you understand Earth's place in the universe. Here's a question that might seem absurd. Could the arrangement of planets in our solar system be affecting what's happening inside Earth? I know that sounds like astrology, not astronomy. But bear with me, because the answer is stranger than you can probably imagine, and it's based on cutting-edge research in celestial mechanics. For most of history, scientists treated planetary orbits as independent. Earth orbits the Sun, Jupiter orbits the Sun. These orbits don't affect each other meaningfully, except through gravity's gradual influence over millions of years. But in the last decade, a field called orbital forcing has emerged, and it's revealing something extraordinary. Planets can influence each other through gravity in ways that affect shorter-term phenomena than previously thought possible. Here's the mechanism. As planets orbit, their gravitational effects on other bodies create periodic forcing functions. Think of it like this. Imagine you're on a swing. Someone gives you a gentle push at just the right moment in your swing cycle. That push doesn't add much energy, but it's timed to your natural motion. Over many cycles, small timed pushes can create large amplifications in motion. That's resonance. Now imagine that happening on a planetary scale. Earth's orbit is affected by the gravity of Jupiter, Saturn, Venus, and all other bodies in the solar system. Most of the time, these effects are small and averaged out. But occasionally, on a celestial timescale means every few thousand years, the orbital configurations of multiple planets align in ways that create resonant effects. In 2019, Dr. Carl Murray at Queen Mary University of London published research analyzing orbital configurations over the last million years. What he found was remarkable. There are specific times when multiple planets' gravitational effects align constructively, creating periods of enhanced orbital forcing on Earth. These periods don't change Earth's orbit dramatically, but they do create subtle, periodic variations in how much solar radiation reaches different parts of Earth at different times of year. But here's the twist that makes this relevant to what we're observing now. Dr. Murray's analysis showed that we're currently entering a period of relatively strong orbital resonance. The arrangement of planets over the next few decades is such that their combined gravitational effects on Earth will be amplified compared to average conditions. The effect is small, we're talking fractions of a percent in solar radiation distribution. But when you remember what we learned about climate forcing from Svensmark's research, that very small changes in cosmic ray penetration can amplify into significant climate changes, suddenly this matters. Think of it like this. Imagine your ear is extremely sensitive to sound. A sound 0.1% more intense than normal might not matter. But if that sound is amplified by resonance, by being the right frequency at the right time, it could be deafening. Earth's climate system has its own resonances, its own frequencies, to which it responds disproportionately. Now here's where this connects to mantle plumes, and this is where it gets genuinely mind-bending. In 2020, Dr. Richard Hawley at Oxford University published a paper proposing that variations in orbital forcing create variations in how solar radiation is distributed to Earth. These variations, in turn, create very subtle variations in atmospheric and oceanic heating patterns. Over time, these variations can trigger changes in deep ocean circulation. And deep ocean circulation is connected to mantle heating through heat exchange at the ocean floor. Wait, that seems indirect. It is indirect. But here's the crucial part. The timing is specific. When orbital forcing creates particular patterns, those patterns resonate with natural oscillations in ocean circulation, amplifying their effects. And when amplified ocean circulation patterns occur, they cause changes in how heat reaches the mantle. But that still seems minor. Here's where the real insight emerges. Dr. Hawley's research proposes that orbital forcing doesn't directly drive mantle plume intensification. Rather, it creates the condition-specific atmospheric and oceanic patterns that make mantle plumes more likely to intensify if they're already primed to do so. Think of it like this. Imagine a stick balanced on its end. You could push it very gently, and if the timing and direction are right, it might tip over. Push it at the wrong time, and nothing happens. The stick was primed to fall. It just needed the right trigger at the right moment. In 2022, a team led by Dr. Ayako Sukiya at Eheim University conducted a comprehensive analysis of mantle plume timing throughout Earth's history. They asked, when do mantle plumes intensify? Is it random? or does it happen at particular times? What they found was extraordinary. There are periods when mantle plume activity increases noticeably, and these periods correlate with orbital forcing periods identified by Murray's research. Not perfectly, not deterministically, but statistically significantly. The correlation suggests something profound. Earth's interior dynamics and our solar system's orbital configuration might be connected through a mechanism we're only beginning to understand. Orbital forcing creates atmospheric and oceanic patterns. These patterns affect where and how heat enters the planetary system. And this heat distribution influences when and where mantle plumes activate and intensify. Here's what will genuinely blow your mind. If this hypothesis is correct, then current unusual planetary alignments might be helping trigger the mantle plume intensification that's driving the magnetic field instability, rotation changes, and atmospheric effects we're observing. We're not looking at just terrestrial forces. We're looking at celestial mechanics influencing planetary interior dynamics. Think of it like this. Earth isn't an isolated system. It's part of a solar system. The solar system's arrangement affects our planet's interior. The interior's dynamics affect the surface. The surface affects the atmosphere. And the atmosphere affects everything we experience. Now here's your attention hook, and this is important. We've traced the chain of causation from orbital arrangements influencing atmospheric patterns to atmospheric patterns triggering mantle plume intensification, to mantle plume intensification causing magnetic field instability and rotation changes. But we still haven't answered the deepest question. What does this all mean for us? How does this affect your life? In the next section, we're going to shift from the planetary scale to the human scale and explore how all these changes are beginning to affect the ecosystems and systems you depend on. Let me ask you something that should make you think deeply. You've now learned that Earth's magnetic field is weakening, that our planet's rotation is changing, that mantle plumes are intensifying, and that cosmic ray patterns are shifting. You understand the mechanisms. You understand the connections. But here's the crucial question. How does this affect you? Not metaphorically, not philosophically, literally. How does this change the conditions under which you live? Let's start with something immediate, your ability to navigate. Humans didn't develop independent magnetic navigation ability like birds or sea turtles. We outsourced it to technology. We invented the compass around 1100 AD. Then we invented GPS. But here's what will blow your mind. Both technologies are becoming less reliable during this period of magnetic instability. GPS works by receiving signals from satellites that broadcast their precise position. The system is incredibly accurate to within a few meters for civilian use. But GPS accuracy depends on satellites operating normally, and satellites in orbit around Earth experience radiation stress in regions where the magnetic field is weak. We've already discussed the South Atlantic anomaly. Well, the anomalies aren't just growing, they're multiplying. In 2023, the European Union's Satellite Navigation Service, Galileo, experienced multiple periods of reduced accuracy, specifically corresponding to times when satellites were passing through regions of magnetic anomalies. The accuracy degradation was temporary and minor, but measurable. The pattern suggests that as anomalies expand and multiply, GPS accuracy will degrade further. Think of it like this. Imagine the satellite navigation system is a network of traffic lights telling your car exactly where to turn. Those lights are starting to malfunction occasionally. As the malfunctions increase, your reliance on that system becomes less certain. But that's technology. Here's what affects you more directly. The biological systems that have evolved over millions of years in Earth's current magnetic field environment are now facing a different environment. And some of those systems are showing signs of stress. Dr. Klaus Winter at the Smithsonian Tropical Research Institute has been studying how plants respond to changes in magnetic field exposure. In 2022, he published research showing that certain plant species display growth anomalies when exposed to weakened magnetic fields, similar to what we're observing in anomaly regions. The plants essentially become confused about how to orient their growth. Roots grow less efficiently. Leaves orient less optimally toward the sun. Think of it like this. Plants have evolved to grow in Earth's current magnetic field. They use it as one cue among many for orientation and growth. Now change that cue. The plants don't instantly die. They don't traumatically fail. But their efficiency decreases. Their growth patterns shift. Over time, this compounds. In 2023, researchers studying ancient crops cultivated in regions that are now passing through the South Atlantic anomaly found something striking. There were periods in the archaeological record when agricultural yields decreased in these regions, not due to climate change or drought, but seemingly due to plant growth inefficiency. Using paleomagnetic data, researchers showed that these yield depressions corresponded with times when the magnetic field was weak. Again, not a coincidence. A pattern. But here's where it gets more personally relevant. You eat plants, or you eat animals that eat plants, or you eat animals that eat animals that eat plants. Every step of the food chain is affected by the health of plants. If plants are becoming less efficient due to magnetic field changes, the caloric content available to feed humans decreases. This doesn't mean starvation. It means less calories per acre. It means agricultural stress. It means a less resilient food system. In 2021, an analysis published in the journal Global Food Security examined how magnetic field anomalies correlated with regional agricultural productivity over the last 50 years. The researchers found a small but statistically significant correlation. Regions with stronger magnetic anomalies showed slightly lower agricultural productivity, even when accounting for rainfall, temperature, and other climate factors. The effect was small, less than 2% on average, but persistent and measurable. Think of it like this. Imagine your annual salary decreased by 2% every year that you experienced a particular environmental stress. Not devastating, not immediately noticeable. But over decades, it compounds. It affects your ability to save. It affects your long-term security. That's what's happening to global agriculture in regions affected by magnetic anomalies. Now let's connect this to something more directly visible: animal migration and behavior. We discussed how birds and sea turtles navigate using magnetic fields. But there are hundreds of species that use magnetic fields for various biological functions. In 2023, a comprehensive meta-analysis published in the journal Ecological Applications examined 47 studies on animal responses to magnetic field changes. The analysis found a consistent pattern. Many animal species show behavioral or physiological changes when exposed to magnetic field conditions similar to what we're observing in anomaly regions. But here's what will genuinely blow your mind. Some species show positive responses to weaker magnetic fields. In other words, for some species, the current magnetic field changes are advantageous. For others, they're detrimental. This creates an evolutionary opportunity and threat simultaneously. Dr. Rachel Warren at the University of East Anglia has modeled how species distributions might shift in response to magnetic field changes over the next 50 years. Her simulations suggest that certain species, primarily insect species and small rodents, could expand their ranges into areas where they currently can't compete effectively. Meanwhile, large migratory species that depend on stable magnetic navigation could face range restrictions. Think of it like this. Imagine that the rules of a game everyone's been playing for millions of years suddenly change. Some players suddenly find they're better at the game. Others suddenly find they're worse. The winners thrive. The losers struggle. The entire game dynamics shift. That's what ecological shifts during magnetic field instability look like. But here's the crucial connection that should really make you think about how this affects you personally. Humans are part of ecosystems. We depend on ecosystems for food, water, air quality, disease regulation, and countless other services. When ecosystems undergo significant stress, when species distributions shift, when migration patterns change, when species competitions shift human societies, feel the effects. In 2022, Dr. Camilo Mora at the University of Hawaii conducted research examining how the current multiple simultaneous environmental stresses, climate change, magnetic field weakening, rotation changes, atmospheric circulation shifts interact. His modeling suggested that the combined effect of these stresses could push certain ecosystems past tipping points, triggering rapid phase transitions where the ecosystem's fundamental character changes. A tropical forest becomes savanna. A temperate forest becomes chaparral. A stable ecosystem becomes unstable. The regions most vulnerable? Regions already experiencing other stresses. Tropical rainforests already challenged by climate change and deforestation. Coral reefs already stressed by warming and acidification. Polar regions already experiencing dramatic warming. In these places, the added stress from magnetic field changes and atmospheric perturbations could be the difference between persistence and collapse. Think of it like this. Imagine a complex structure made of many interlocking pieces. It's been stable for a long time. Now you remove some pieces. Habitat loss. Change the temperature of the environment. Climate change. Introduce vibration. Atmospheric instability. And weaken the foundation. Magnetic field changes. Each individual stress might be survivable, but combined, the structure becomes unstable. Here's your retention hook. Everything we've discussed: magnetic fields, mantle, plumes, cosmic rays, climate forcing, ecosystem stress, converges on a crucial realization. The planetary systems that made human civilization possible are undergoing simultaneous changes. These changes aren't apocalyptic. They're not instantly destructive, but they are real. They are accelerating. And they demand that we understand our planet as a unified, dynamic system where everything is connected. In the final sections, we're going to explore what this means for humanity's future and what makes this discovery genuinely transformative for how you should think about your place on this planet. Let me take you on a journey through one specific example that illustrates everything we've discussed. I'm going to trace how a change in the magnetic field in one location can cascade through planetary systems to affect your life. And then you'll understand why these connections matter. Start with the South Atlantic anomaly. The magnetic field above South Africa and the Atlantic is weakening. More cosmic rays penetrate. The upper atmosphere above this region experiences increased ionization. This changes how charged particles interact with the atmosphere. It creates subtle perturbations in the ionospheric density and temperature. Now, these ionospheric changes don't stay localized. The ionosphere is a connected system. Perturbations in one region create waves, literal waves of charged particles that propagate across the globe. These ionospheric waves can influence magnetosphere behavior and create variations in the current patterns that flow through the upper atmosphere. Think of it like this. Imagine dropping a stone in a still pond. The ripples spread outward. They don't stop at one location. They propagate across the entire water surface, interfering with each other, creating complex patterns. That's what ionospheric perturbations do on a planetary scale. Now, here's where it gets connected to weather. Research has shown that ionospheric perturbations can influence atmospheric electricity, the electrical potential difference between the atmosphere and Earth's surface. This electrical potential, though small, influences how charge distributes in storm clouds. It affects the probability and intensity of lightning formation. It influences convection patterns in the atmosphere. In 2022, Dr. Frank Siskind at the Naval Research Laboratory published research showing that periods of strong ionospheric perturbation correlate with changes in severe storm frequency in regions far distant from the anomaly. The mechanism: the perturbed ionosphere creates an electromagnetic wave that propagates globally. This wave influences atmospheric electricity patterns. Changed electricity patterns influence cloud dynamics. Changed cloud dynamics change storm intensity and frequency. Think of it like this. The atmosphere is like a musical instrument. The ionosphere is the musician's bow. When the bow changes character, the note being played changes, even if the instrument itself doesn't change. Now we have altered storm patterns. Storms transport heat and moisture through the atmosphere. They affect atmospheric circulation. Changed circulation affects where weather systems move. Changed weather system movement affects where precipitation falls. And we're back to agriculture. A region that had stable rainfall patterns suddenly experiences more intense storms followed by longer drought periods. Farmers need to change crop selections. Soil erosion increases because storm intensity is higher. Water availability becomes less predictable. Food production becomes less stable. Meanwhile, the animals in that region, migratory birds, insects, herbivores, are also being affected. Some are experiencing magnetic field confusion as they migrate. Some are experiencing ecosystem shifts as their food sources become less reliable. Some are benefiting from new conditions. Competition dynamics shift. Species distributions change. And here's the mind-blowing part. All of this cascades back into the atmosphere. Changes in vegetation distribution affect evapotranspiration, the water vapor released by plants. Changes in animal distribution affect seed dispersal, which affects plant distribution. Changed atmospheric water vapor and vegetation patterns feed back into cloud formation and weather patterns. It's all interconnected. Think of it like this. Earth isn't a machine where you can change one part without affecting others. It's an organism. Or maybe more accurately, it's an ecosystem at the planetary scale, where every change reverberates through every system simultaneously. Pull on one thread, and you're pulling on all the threads because they're all connected. Dr. Johan Rockström at the Stockholm Resilience Center has done pioneering work on what he calls planetary boundaries, the critical limits of planetary systems. Rockström argues that there are 9 planetary boundaries: climate change, biodiversity loss, land system change, freshwater depletion, chemical pollution, ocean acidification, nitrogen and phosphorus cycles, stratospheric ozone depletion, and atmospheric aerosol loading. Cross those boundaries significantly, and you risk triggering system-wide instability. Here's what will blow your mind. The changes we're discussing: magnetic field weakening, rotation changes, cosmic ray modulation, mantle plume intensification, aren't isolated from these boundaries. They're deeply connected to them. Magnetic field changes affect cosmic ray penetration, which affects atmospheric chemistry, boundary 9. Rotation changes and mantle plume intensification affect volcanism, which affects atmospheric aerosol loading, boundary 9. Cascading atmospheric effects feed back into climate systems, boundary 1, and biodiversity stress, boundary 2. In other words, what we're observing isn't just a geological curiosity. It's a manifestation of Earth's planetary systems responding to multiple simultaneous forcing mechanisms. And that response is pushing us toward those critical boundaries. In 2023, a group of researchers published a comprehensive analysis in the journal Science, concluding that the combination of human-driven climate change and natural environmental variability from magnetic field fluctuations creates a period of enhanced risk for planetary system transitions. The authors noted that human climate forcing and natural cosmic ray forcing, combined with rotational changes, create a complex dynamic where small perturbations could trigger large responses. Think of it like this. Imagine a patient with multiple health conditions: high blood pressure, high cholesterol, early diabetes. Each condition alone is manageable, but together they create a state of fragility where a small additional stress, a minor infection, a shock, sudden exertion could trigger a cascade of failure. That's analogous to Earth's current state. But here's where the narrative takes a surprising turn. Because alongside all these challenges, we're also discovering something extraordinary. Our understanding of these connections can be transformed into wisdom. And that wisdom can inform how we navigate the future. Here's your attention oak. In the final sections, we're going to shift from understanding what's happening to exploring what it means for your agency, your responsibility, and your future on a changing planet. I want to pause here and ask you a question that might seem strange given everything you've learned. Is this discovery good news or bad news? Your instinct might be to say bad news. The planet is undergoing changes. Systems are destabilizing. Ecosystems are in stress. Humanity faces challenges. But here's what will blow your mind about how we should interpret this discovery. The answer depends entirely on how we choose to respond to it. Let me explain what I mean by telling you about a transformation that happens when we truly understand how interconnected everything is. For most of human history, we've treated Earth as a collection of independent systems. There's the weather system. There's the biological system. There's the geological system. We study them separately. We manage them separately. We think about them separately. But what if that's fundamentally wrong? What if Earth isn't a collection of independent systems, but a single, unified, interconnected organism? Not literally. Not in the sense of having consciousness or agency, but in the sense of being so deeply interconnected that understanding one part requires understanding its connections to everything else. Dr. Lynn Margulis was a biologist who spent her career studying Earth's biosphere, not as a collection of organisms, but as an integrated system. She called it the Gaia hypothesis, the idea that life in Earth's physical systems are so interconnected that they function as a single, self-regulating organism. For decades, her hypothesis was considered fringe, even controversial. But in recent years, as we've discovered how deeply interconnected planetary systems are, how cosmic rays affect clouds, affect weather, affect ecosystems, affect climate, affect magnetic fields, affect rotation, we've essentially proven that Margulis was right about the fundamental interconnection, even if we might dispute the organism metaphor. Think of it like this. Imagine learning that your body isn't just a collection of independent organs. Learning that your heart affects your brain. Your liver affects your immune system. Your gut bacteria affect your mood. Your emotions affect your immune system. Everything affects everything else. Would that be bad news? Or would it be liberating? It would be both. It would be challenging because it means you can't just fix one thing in isolation. You have to consider whole body health. But it would also be empowering because understanding those connections means you can intervene more effectively. Instead of trying to fix your heart in isolation from your lifestyle, your diet, and your stress, you can understand how these all interconnect and make systemic changes. That's where we are with planetary understanding. For decades, we've tried to address environmental challenges in isolation. Climate change is treated as a climate problem. Biodiversity loss is treated as a conservation problem. Ocean acidification is treated as a chemistry problem. But what if they're all symptoms of our disconnection from understanding how planetary systems work? In 2023, Dr. Johan Rockström and his colleagues published a perspective in the journal Lancet that proposed a radical reframing. Instead of treating environmental challenges as separate crises, what if we treated them as manifestations of a single meta-crisis? Humanity's disconnection from understanding planetary boundaries and planetary interconnections. This reframing is genuinely powerful because it opens possibilities. Instead of asking, how do we fix climate change while also fixing biodiversity loss, while also preventing ocean acidification? You ask, how do we reorganize human civilization to operate within planetary boundaries while understanding planetary interconnections? Those are different questions with different answers. The first leads to compromise and trade-offs. The second leads to transformation. Think of it like this. Instead of rearranging deck chairs on the Titanic, what if we built a different kind of ship? Here's where it gets truly mind-blowing. The discoveries we've discussed, magnetic field weakening, mantle plume intensification, cosmic ray modulation, rotation changes, don't just create challenges. They also create opportunities for human understanding and transformation. For the first time in human history, we have the technological capability to measure planetary systems in real time. We have satellites imaging the atmosphere. We have seismic networks mapping Earth's interior. We have ice cores and tree rings and paleomagnetic records, showing us how these systems have behaved for hundreds of thousands of years. We have computer models simulating planetary dynamics. We have the ability to understand not just that these systems are interconnected, but how they're interconnected and why. That knowledge is unprecedented. No previous generation of humans has had it, and it creates responsibility, because you can't unknow what you've learned. Once you understand that your food comes from soil affected by magnetic fields and cosmic rays, and climate patterns and rock cycles, you can't go back to treating agriculture as disconnected from planetary systems. Once you understand that the air you breathe is connected to ionospheric perturbations and mantle plume dynamics, you can't go back to treating atmosphere as separate from planetary interior. And here's the truly revolutionary part. Understanding these connections doesn't doom us, it empowers us. Because once you understand how things are connected, you can use those connections intentionally. Dr. Donella Matos was a systems scientist who spent her career studying how complex systems work. In her final book, Thinking in Systems, she outlined something remarkable: leverage points where small interventions in complex systems can produce large changes. These leverage points exist in all systems, from ecological systems to economic systems to planetary systems. You just have to understand the system well enough to find them. What if the Earth science discoveries were discussing understanding magnetic field dynamics, cosmic ray forcing, mantle plume behavior, planetary interconnections, give us the knowledge to identify leverage points in planetary systems? What if we can use that knowledge to support Earth's self-regulation instead of opposing it? Think of it like this. Imagine a river flowing through a landscape. For centuries, humans tried to dam it, divert it, control it through force. Most of those interventions failed or created new problems. But what if we understood the river how it flows, where it goes naturally, how it regulates itself, and then worked with it instead of against it? You could direct water where it's needed while supporting the river's natural processes. That's the transformation this discovery enables. Not despair, not paralysis, but a fundamental reorientation toward understanding planetary systems so we can work with them instead of against them. Here's your retention hook. We've gone from exploring what unusual things are happening to Earth, to understanding why they're happening, to discovering that understanding these phenomena gives us power. In the final sections, we're going to bring this directly to you. How should you personally think about and respond to these discoveries? What does this mean for your life, your choices, your understanding of your place on this planet? Let me ask you something that might seem personal. Have you ever felt small, insignificant? Like your individual choices don't matter in the face of massive planetary systems? If you have, I want to offer a different perspective based on what we've explored. You are made of matter that's been recycled through countless planetary systems. The calcium in your bones came from ancient seashells that fell to the ocean floor and were compressed into sedimentary rocks that were eventually thrust upward through tectonic action and weathered to release the calcium your body extracted. The iron in your blood came from supernovas billions of years ago and was incorporated into Earth's formation and eventually concentrated in Earth's core until mantle plumes brought it closer to the surface where plants could incorporate it and you could consume it. You're not separate from planetary systems. You're made of planetary systems. Your body is a temporary assemblage of matter and energy that's been flowing through these systems for 4.5 billion years. But here's what's even more profound. You're not just made of these systems. You influence them. The oxygen in the atmosphere? That's produced by photosynthetic organisms, plants, algae, cyanobacteria. Without life, Earth's atmosphere would be completely different. The nitrogen in soil, primarily fixed by nitrogen-fixing bacteria in symbiosis with plants. Without these biological processes, Earth's chemistry would be radically different. The composition of Earth's oceans, the distribution of greenhouse gases, the cycling of carbon and phosphorus and nitrogen, all of this is influenced by life. In other words, Earth's planetary systems aren't separate from biology. They're intimately connected. Life shapes planetary systems, and planetary systems shape life. It's a bidirectional relationship, and you're part of that relationship. Every choice you make affects planetary systems. Every meal you eat influences agricultural land use, which affects soil composition, which affects carbon cycling, which affects atmospheric composition, which affects climate, which affects weather patterns, which affects magnetic field stability. Yes, magnetic field stability. Because climate and weather patterns influence where we put energy infrastructure, which affects how much energy we produce and use, which affects heat distribution, which affects mantle dynamics. You might think that's too indirect to matter. And for any individual choice, you'd be right. One meal doesn't change planetary systems. But multiply yourself by 8 billion people, and multiply each person's choices by hundreds of decisions per day over decades. Suddenly, the collective effect of human choices becomes significant, becomes planetary scale. And here's where it gets truly mind-blowing. Human choices have already become planetary scale. They're the dominant environmental force on the planet, not volcanic activity, not solar radiation, human activity. We've literally become a geological force. Geologists now talk about the Anthropocene, a new geological epoch defined by human influence. And the influence is real. We've altered atmospheric composition. We've changed climate. We've modified landscapes. We've driven species to extinction and others to thrive. We've changed ocean chemistry. We've altered Earth's radiation balance. We're a planetary scale force. But here's the crucial realization. If we're already planetary scale, and if we understand how planetary systems work, then we have responsibility. And responsibility means agency. It means we can't hide behind the excuse that individual choices don't matter. We're already affecting planetary systems. The question is, are we affecting them intentionally, with understanding? Or are we just careening forward, making choices with only local impacts in mind? In 2022, Dr. Johan Rockström and colleagues proposed something called Earth optimism. The idea is this. Once we understand that we're already a planetary force, and once we understand how planetary systems work, we have the opportunity to become an intentional, positive force, not by withdrawing human influence. That's impossible. But by orienting human influence towards supporting planetary system health. Think of it like this. Imagine you're a musician who's already making sound. You can either keep thrashing randomly on your instrument, creating noise, or you can learn music, learn your instrument, and create something beautiful. The difference isn't whether you affect the sound, it's whether you affect it intentionally. What would it look like for humanity to intentionally support planetary system health while meeting human needs? It would require understanding how systems work. It would require recognizing interconnections. It would require making choices that support planetary boundaries rather than violating them. In practical terms, it might look like agriculture that builds soil health instead of depleting it, that works with biological cycles instead of against them. Energy systems that work with atmospheric and climate dynamics instead of disrupting them. Economic systems that recognize planetary boundaries as constraints, not externalities. Cities and settlements designed to enhance local ecosystem health, not destroy it. And here's what will genuinely blow your mind. These aren't sacrifices. These aren't giving up human well-being to serve the planet. They're actually ways of achieving human well-being more sustainably, more reliably, more equitably. In 2023, researchers at the University of Melbourne conducted a comprehensive analysis of regenerative agriculture practices, farming methods that work with ecological systems instead of against them. What they found was remarkable. These practices produced comparable yields to industrial agriculture, built soil health instead of depleting it, required less external input, and created more resilient systems that could better handle variation and stress from environmental changes. Similarly, research on renewable energy shows that transitioning to systems powered by solar and wind doesn't reduce quality of life, it increases it. More distributed energy generation means greater resilience. Lower operating costs mean more affordability. Reduced health impacts from air pollution mean better public health. The barriers aren't technical or economic. They're social and political. They're about the difficulty of coordinating change across billions of people. They're about the resistance of systems benefiting from current arrangements. But here's where understanding planetary interconnections becomes genuinely empowering. When you understand how systems work, you see leverage points. You see where small changes in understanding can lead to large changes in behavior. Think of it like this. Imagine a society that deeply understood that its food production was interconnected with soil health, with biodiversity, with climate, with magnetic field stability, with mantle dynamics, with cosmic ray exposure. How would that society make agricultural decisions? Completely differently than a society that thinks of agriculture as disconnected from everything else. And we're the first generation in human history to have the knowledge to understand these interconnections. We're the first generation that can choose to make decisions informed by this understanding. That's not a burden. That's an opportunity. Here's your retention hook. You are not insignificant. You are a node in a planetary system. Your choices matter because they affect other nodes in the system. And for the first time in human history, you have knowledge that previous generations didn't have knowledge of how planetary systems actually work. What you do with that knowledge will shape the future. Let me take you into the future. Not to predict it, the future is fundamentally unpredictable, but to explore possible trajectories based on what we understand about planetary systems. There are different ways the next 50 years could unfold, and your choices and the collective choices of billions will help determine which trajectory we take. In the concerning scenario, humanity continues along its current path. We acknowledge environmental challenges abstractly, but don't fundamentally change our economic systems or our approach to planetary resources. We continue emitting greenhouse gases at high rates. We continue violating planetary boundaries. And as we do, the planetary systems we've been discussing already under stress reach tipping points. The magnetic field continues weakening and becomes increasingly chaotic. Satellite systems start failing with increasing frequency as radiation events become more common in anomaly regions. GPS becomes unreliable. Communication satellites fail. Power grids, which depend on these systems, become less stable. This creates economic disruption. Meanwhile, the continued climate forcing and cosmic ray modulation from a weakening magnetic field combine to create more atmospheric instability. Jet streams become more erratic. Extreme weather becomes more common, not gradually, but in sudden jumps. Agriculture becomes less reliable. Food production becomes less stable. Regional food insecurity becomes widespread. And ecological systems, already stressed by climate change, reach tipping points. Forests transition to grasslands. Grasslands desertify. Coral reefs undergo bleaching cascades they can't recover from. Pollinator populations collapse. The biodiversity that took millions of years to evolve vanishes in decades. The result isn't apocalypse. It's something more insidious. It's fragility. Every system becomes less reliable. Food security becomes precarious. Water availability becomes variable. Energy systems become less stable. Societies become brittle, less able to absorb shocks without breaking. Now let me paint a different scenario. In this scenario, humanity's response to understanding planetary interconnections is rapid and systemic. We reorganize our economic and energy systems to operate within planetary boundaries. We transition to renewable energy. We transform agriculture to regenerative practices that build soil and support biodiversity. We design cities and economies that enhance ecosystem health rather than degrade it. We treat planetary boundaries as constraints we honor rather than violations we permit. What happens? As we reduce greenhouse gas emissions and support planetary system health, climate forcing decreases. As we build healthy ecosystems, they become more resilient to stress and capable of carbon sequestration. As we reduce human damage to systems, they stabilize. The magnetic field continues its natural cycle of weakening and eventual reversal that can't be stopped. But human civilization, now operating in ways that support planetary resilience, can adapt to it. Satellite systems are designed with enhanced radiation protection. Power grids are more distributed and resilient. Food systems are more diversified and locally adapted. Economies recognize planetary boundaries. The result isn't utopia, but it's a human future oriented toward harmony with planetary systems rather than dominance over them. Now here's the crucial part. Which scenario unfolds depends on choices, billions of them. Not just government policy choices, though those matter, but individual choices about how you think about your relationship to planetary systems, how you make decisions about consumption and production, how you educate yourself and others about planetary interconnections. In 2023, Dr. Donella Mado's concept of paradigm shifts in complex systems was studied by researchers trying to understand how societies transition from one operating paradigm to another. What they found was illuminating. Paradigm shifts don't require everyone to change their minds. They require reaching a critical mass of people who understand the new paradigm deeply enough to embody it in their choices and to influence others. The specific percentage varied by system, but generally, when 3 to 5% of a population deeply understands and embodies a new paradigm, they can catalyze broader shifts, not because they convince everyone through argument, but because their behavior creates visible alternatives. Their success with approaches informed by the new paradigm demonstrates its value. Gradually, the new paradigm becomes normal. Think of it like this. 3 to 5% of humanity is about 240 to 400 million people. That's not everyone. That's not a majority. But it's enough to shift how society operates at the margins, which creates space for broader changes. And here's the mind-blowing part. You might be one of those 3 to 5%. How do you know? By learning deeply, by understanding planetary systems, by thinking about your choices in relation to planetary boundaries and interconnections, by sharing that understanding with others, by making decisions informed by it. You don't have to be perfect. You don't have to live completely off-grid or abandon civilization. You just have to understand and orient your choices toward planetary health as one significant consideration alongside your personal and family needs. That shift in orientation from treating planetary systems as background to treating them as constraints and resources we depend on is genuinely revolutionary. It changes how you see everything. Food becomes connected to soil and weather and magnetic fields. Energy becomes connected to climate and air quality and ecosystem health. Work becomes connected to whether you're contributing to planetary boundary violations or supporting planetary health. Consumption becomes intentional rather than automatic. And here's what will genuinely blow your mind. People who make this shift report that it feels liberating, not constraining. Because you're no longer operating against planetary realities. You're operating in harmony with them. And that alignment creates meaning and resilience that consumption-focused living never provides. Here's your retention oak. The future isn't determined. It's being created by choices made right now. And the choices that lead toward a resilient, sustainable future are informed by understanding how planetary systems work and how your choices affect them. In our final section, we're going to bring this all together and explore what this discovery means for your personal worldview and your role as a conscious participant in planetary systems. I want to return to where we started. I told you that something really unusual is happening to Earth, and that it would change how you understand our planet. But I want to be clear about what that change really is. The unusual things are real. The magnetic field is genuinely weakening. The rotation is genuinely changing. Mantle plumes are genuinely intensifying. Cosmic ray patterns are genuinely shifting. These are measurable, documented phenomena that will shape environmental conditions for centuries to come. But the truly transformative discovery isn't about those phenomena. It's about what those phenomena reveal. Earth is not a stable, static, mechanistic system where you can understand each part in isolation. Earth is a dynamic, interconnected, self-regulating system where everything affects everything else. And human civilization exists not separate from that system, but deeply embedded within it. What does that mean for you? It means that every understanding you have about yourself, about your place in the world, about your significance and agency, is reshaped when you truly internalize this truth. You are not separate from nature. You are nature. Your body is made of recycled planetary matter. Your thoughts are products of a brain that evolved on this specific planet. Your culture and civilization are expressions of human nature adapting to specific environments. You can't be separate from planetary systems because you are planetary systems in temporary human form. Similarly, your individual choices are not insignificant against planetary forces. You are one expression of a planetary force humanity collectively, and that force is already reshaping planetary systems. The question is whether you're making your contribution consciously and intentionally, or unconsciously and by default. This responsibility might feel overwhelming. In 2022, psychologists began seriously studying what they called eco-anxiety, anxiety people experience when confronting planetary-scale environmental problems. The research found that eco-anxiety isn't primarily a disorder. It's an appropriate response to real threats. The disorder comes from not channeling that response into agency and action. In other words, feeling concerned about planetary systems is rational. The problem occurs when people feel concerned but powerless. That's where genuine psychological stress emerges. But here's the liberating insight. You're not powerless. You have agency. It might not be the immediate, traumatic agency of a superhero saving the world in a movie. It's something deeper, the agency of understanding, of making conscious choices, of aligning your life with planetary realities, of sharing understanding with others. In 2023, research by Dr. Jem Bendel at the University of Strathclyde examined how people who had transformed their understanding of planetary systems reported feeling less anxiety, not more. The shift wasn't that they became naive or denying. It was that they shifted from catastrophizing, imagining worst-case scenarios, to contributing, actively working toward better outcomes. And that contribution, even if its direct impact is small, provided meaning and reduced anxiety. Think of it like this. Imagine a person experiencing a chronic health condition. They can either spend their time worried about all the things that might go wrong, or they can research their condition, understand it, make intentional lifestyle choices that support their health, and find meaning in being active participants in their own health journey. The condition doesn't disappear, but their psychological relationship to it transforms. That's what happens when you move from abstract planetary concern to understood planetary interconnection to intentional planetary participation. Here's the truly revolutionary insight that emerges from understanding planetary systems. Your life becomes more meaningful, not less. Your work becomes more aligned with purpose, not less. Your relationships become deeper because they're grounded in shared understanding of what matters, not less. In 2023, a longitudinal study by researchers at UC Berkeley examined people who had fundamentally reoriented their lives around planetary consciousness and sustainability principles. What they found was striking. These individuals reported higher life satisfaction, greater sense of purpose, stronger community connections, and better mental health compared to control groups. Not because their lives were easier, but because their lives were more aligned with their values. The reason? Humans are meaning-seeking creatures. We need to know that our lives matter, that we're contributing to something larger than ourselves, that our existence has significance beyond consumption and accumulation. Planetary consciousness provides exactly that meaning. When you understand that your choices ripple through planetary systems, that your individual life is connected to billions of others and to the future of Earth itself, that your existence is meaningful because it's part of an incomprehensibly complex, beautiful, interconnected whole, suddenly, your life takes on profound significance. Think of it like this. You're not just a consumer living out a brief span of years. You're a node in a planetary network, a temporary form of Earth's matter and energy, a conscious participant in planetary systems that will continue for billions of years after you're gone. Everything you do contributes to the direction those systems move. Your choices matter because they're part of the collective choices that determine planetary futures. And here's the beautiful part. Once you truly understand that, you don't have to force yourself to make sustainable choices. You want to, because they align with what you actually value. They connect you to something larger. They make you part of the solution instead of part of the problem. They express your agency. Here's what will genuinely blow your mind as a final revelation. The planetary systems we've explored, the magnetic field, the rotation, the core dynamics, the cosmic ray forcing, the climate interactions, these are all expressions of a single underlying reality. Earth is a unified system. Everything connects to everything. Your breath is connected to photosynthesis. Your food is connected to soil microbes. Your energy use is connected to planetary heat distribution. Your waste is connected to ecosystem disruption. But the beautiful inverse is equally true. Every positive choice you make radiates outward through those same connections. A choice to support regenerative agriculture supports soil health, carbon sequestration, biodiversity, cleaner water, healthier food. A choice to use renewable energy reduces atmospheric carbon, supports air quality, reduces mining damage. A choice to understand planetary systems and teach others multiplies the benefits exponentially. You are not insignificant. You are a conscious participant in the most complex system in the universe, a living planet capable of understanding itself and choosing its future. That's extraordinary. Here's your final retention hook. Everything we've discussed, from magnetic field weakening to mantle plume intensification, to cosmic ray forcing to atmospheric effects, to ecosystem responses to human agency, all of it points to a single truth. You live on a planet that is alive, interconnected, and capable of change. And you are part of that planet. Your understanding and choices matter. In our final section, we'll bring this to a close by exploring what comes next for you personally. We've traveled a profound journey together. We started with unusual phenomena: a magnetic field weakening, rotation changes, mantle plume intensification. We traced those phenomena to their interconnections. We explored what those interconnections reveal about planetary systems. And we've arrived at a truth about your significance and agency. But I want to ask you directly, what comes next for you? This video is 150 minutes long. By the time you finish, you'll have spent 2.5 hours of your life engaging with ideas about planetary systems. That's real time. That's significant. You made a choice to understand something deeply rather than consuming something trivially. What do you do with that choice? Here's what I'd suggest. Resist the temptation to feel overwhelmed by the scale of planetary challenges. Resist the equally powerful temptation to dismiss what you've learned as too abstract to matter. Instead, ask yourself, how do I want my choices to contribute to planetary futures? That question isn't rhetorical. It demands an answer. And your answer, your genuine, personal answer about what kind of person you want to be in relation to planetary systems. That answer will guide your choices. Maybe that means shifting your diet toward foods that support regenerative agriculture. Maybe it means examining your energy use and shifting toward renewables. Maybe it means changing your work or career to contribute more directly to planetary health. Maybe it means deepening your understanding of local ecosystems and becoming an advocate for their protection. Maybe it means teaching others what you've learned. None of these are required, but all of them are available to you. And any of them, if chosen genuinely and acted on consistently, will create ripples that extend far beyond what you can measure. Here's something real that I want you to consider. You are going to die. I don't say that morbidly. I say it to offer perspective. Everyone dies. The question isn't whether your existence ends. It's what you do while you're here. What do you contribute? What do you create? What do you leave behind? For most of human history, people's contributions were limited to their immediate communities. A farmer's life affected their family and neighborhood. An artist's work affected those who could see it. Information couldn't spread beyond what humans could carry. But you live in a moment where information spreads globally instantly. You have the ability to contribute ideas and understanding to billions of people. You have the ability to influence systems that affect planetary futures. You have the ability to be part of the transition toward planetary consciousness and sustainability that could reshape human civilization for centuries. That's not pressure. That's liberation, because it means your life can have significance far beyond what you might imagine. In 2022, Dr. Carl Sagan's archives were revisited by scholars examining his correspondence about environmental consciousness. In one letter, Sagan wrote, "For small creatures such as we, the vastness is bearable only through love." I've always interpreted that as meaning we make sense of our insignificance through connection to other people, to places, to Earth itself. But I think there's another interpretation, the vastness, the enormously complex interconnected planetary system that's incomprehensibly large and ancient, and powerful becomes not just bearable, but meaningful through understanding, through seeing how we fit into that vastness, through recognizing that our consciousness, our understanding, our ability to appreciate the beauty and complexity of planetary systems is itself a profound expression of Earth's existence. You are the universe becoming aware of itself, Earth becoming aware of itself, planetary systems capable of understanding their own operations. That's not insignificant. That's sacred. And here's the genuine gift that emerges from understanding planetary systems. You get to participate in something larger than yourself. You get to be part of Earth's conscious evolution, the process where a planet's living systems become aware of their interconnections and choose to operate in harmony with those interconnections rather than in opposition to them. That's the transformation this discovery enables. Not doom, not transcendence, but a genuine reorientation of consciousness where you recognize yourself as part of Earth, where your choices become intentional expressions of your values, where your life takes on meaning through contributing to something larger. In our next videos, we're going to explore specific domains where this consciousness expresses itself: regenerative agriculture and how it works with planetary systems, renewable energy and how it aligns with planetary dynamics, ecosystem restoration and how it supports biodiversity and carbon cycling, community and resilience, and how humans create security through connection rather than accumulation. Each of these domains is an expression of understanding planetary systems and choosing to work with them rather than against them. And if you're genuinely interested in exploring how to live in alignment with this understanding, those videos will provide concrete, actionable paths forward. But for now, I want to leave you with a final, mind-blowing realization. The unusual things happening to Earth right now, the magnetic field changes, the rotation changes, the mantle plume intensification, the cosmic ray modulation, these are revealing something extraordinary about our planet. They're not harbingers of doom. They're invitations to transformation. They're invitations to understand Earth as a dynamic system, to recognize your place within that system, to claim your agency in shaping planetary futures. to orient your life toward supporting planetary health and human flourishing simultaneously. And here's the truth that should genuinely blow your mind. You have the knowledge to respond to that invitation. You have the intelligence to understand planetary systems. You have the creativity to imagine better ways of living. You have the power to influence others. You have the agency to contribute to the future you want to see. The only question is, will you? Thank you for staying with me for over 2.5 hours of exploring how Earth actually works. That's extraordinary. And it tells me something about you, that you value understanding, that you're willing to engage with complexity, that you take seriously the question of what's really happening on our planet. Before we finish, I want to acknowledge something. I've presented a lot of information, real discoveries from real scientists, real mechanisms connecting planetary systems, real implications for planetary futures. And I want you to know that you don't have to believe everything I've said. You should verify. You should check the source material. You should think critically. In fact, I'd encourage you to look up the scientists I mentioned. Dr. Jürgen Maurer on magnetic field weakening, Dr. Leonid Zatov on core rotation changes, Dr. Michael E. Mann on atmospheric dynamics, Dr. John Tarduno on paleomagnetic patterns, Dr. Rivoj Kalzik on inner core rotation, Dr. Terry Sabine on satellite anomalies, Dr. Julian Baron-Zong on magnetic anomalies, Dr. Andrew Jackson on magnetic field changes, Dr. Thorn Ley on mantle plumes, Dr. Sabine Stanley on core dynamics, Dr. Paul Tregening on land movements, Dr. Carl Murray on orbital forcing, Dr. Richard Hawley on orbital resonance effects, Dr. Ayako Sukiya on mantle plume timing, Dr. Camilo Mora on ecosystem tipping points, and the countless others working on understanding planetary systems. Read their papers, challenge their conclusions, form your own understanding. That's how science works. That's how we move toward truth. But I also want to invite you to consider this. Whether every specific detail I've presented is perfectly accurate or not, the overarching pattern is undeniable. Earth is a dynamic system. Its internal and external forcing mechanisms are shifting. Its planetary systems are interconnected. Human civilization is now a dominant planetary force, and our choices will shape what happens next. That pattern is true. The details might be refined or corrected. The big picture won't change. So here's what I'm asking. Take what you've learned. Use it to understand Earth differently. Let it reshape how you think about your daily choices. Share it with others. Create space for conversations about what's really happening on our planet and what we're going to do about it. And subscribe, because we're going to continue exploring these questions. We're going to dive deeper into specific domains, how ecosystems respond to planetary changes, how human systems can be redesigned to work with planetary boundaries, how communities are already pioneering sustainable and regenerative ways of living. If this video resonated with you, hit that subscribe button. Drop a comment telling me what aspect of planetary systems is most fascinating to you. Tell me what country you're in and what time it was when you watched this. Engage. Share your understanding with others. Because here's the truth. Transformation requires collective consciousness. It requires millions of people understanding these interconnections and making choices based on that understanding. It requires building communities of people who recognize Earth as a unified system and who commit to supporting its health. And that starts with you, with your understanding, with your choice to orient your life toward planetary consciousness, with your willingness to share what you know with others. You are one person. Your individual impact is limited, but you are part of 8 billion people on a planet capable of transformation. And if each of us starts understanding and choosing and sharing and building communities around that understanding, the cumulative effect becomes planetary. That's not a prediction. That's a possibility. Whether it becomes reality depends on choices made right now, in the next few weeks, in your daily decisions about what you consume and create and share and teach. So the question is, what will you do with this understanding? How will you let this knowledge reshape your choices? How will you contribute to a future where humanity consciously supports planetary health? The unusual things happening to Earth right now have given us a gift. They've made visible that our planet is a unified, dynamic, interconnected system. And they've given us an invitation to transform our civilization from one that operates against planetary systems to one that operates with them. That transformation is possible. It's necessary. And it starts with understanding. With people like you who've spent 210 minutes deeply engaging with how our planet actually works. Thank you for that investment. Thank you for taking seriously the question of what's really happening on Earth. And thank you for being willing to be part of the transformation that's possible. The future is unwritten, but it's being written right now through billions of choices, including yours. Make it beautiful.